Have you ever stopped to think about how we actually talk to computers? I mean, these are machines that only get on or off, right? Yet they run our entire world. Well, it all comes down to programming languages. So today, we're going to break it all down and take a journey through 5 distinct generations, climbing what's called the ladder of abstraction. It's going to be fun. Let's get into it.
So here's the plan. We'll kick things off at the very bottom with the machine's native language. Then we'll see a major leap forward into something humans can actually read. After that, we hit the big one, the era of programming for people. From there, it gets really interesting as we explore the shift from telling the computer how to do something to just telling it what we want. And we'll wrap it all up on the cutting edge, the logic-driven AI frontier.
You know, this right here, this is the fundamental question. It's the puzzle that has driven every single innovation in programming for decades. The entire story is really about one thing. How do we bridge that massive gap between our own creative, messy, abstract thoughts and the super simple, rigid world of zeros and ones inside a computer? So think of this flowchart as our roadmap for today. We're going to start right at the bottom with the first generation languages, or 1GLs, and climb our way step by step all the way to the 5th. And you'll notice a theme as we go. Each step up this ladder takes us further away from the raw hardware and gets us closer and closer to the way we humans actually think.
All right, let's start our climb at the very, very bottom, at the foundation. We're talking about the low-level languages that speak directly to the machine itself, the first and second generations.
So, first-generation language, 1GL for short, is pure, unadulterated machine code. This is the native tongue of the computer's brain, the CPU. And because the CPU gets it directly, no translation needed, it's blazing fast. But here's the catch. For a human, it's basically impossible to read or write.
Just look at this. I mean, what even is that? This is an actual computer instruction. It's just a raw string of zeros and ones. Can you imagine trying to build an app like this? A single typo, 1 0 that should have been a 1, and your whole program is toast? It would be an absolute nightmare. This was programming at its most brutal.
Yeah, clearly, that couldn't last. Something had to give. And that brings us to the second generation language, or 2GL, which you probably know as assembly language. This was the first and maybe most important step towards making code readable for humans. Instead of just raw binary, programmers could now use these simple, memorable codes, they're called mnemonics, to represent those gnarly machine instructions.
And this slide right here, this is where you really see the aha moment. That long binary string on the left, 10110000, that might tell the computer to move a piece of data. Well, in assembly, you could just write MOV. Now, it's still super low level. It's still tied directly to the hardware, but come on. It's a universe away from trying to write in pure zeros and ones.
Okay, so everything we've seen so far, it was really about making life a little less miserable for the programmer, but it was still programming for the machine. This next step, though, this was a flat-out revolution. This is the moment programming really started to be for people. Third-generation languages, or 3GLs, are what most of us think of when we hear the word programming. These are high-level languages. They use words that look like English, they use math symbols you'd recognize from school, and here's the key. They abstract away the hardware. That's a fancy way of saying you don't have to worry about the nitty-gritty anymore. This was also huge because it made the code portable. You could write it once and run it on totally different machines.
And man, this generation gave us some absolute legends of the programming world. You had early giants like Fortran and COBOL that powered science and business, then C and C++ became the backbone for, well, pretty much everything, and of course, modern powerhouses like Java and Python are still running the show today. They're all part of this incredible 3GL family.
And this right here just shows you what a massive leap this was. Over on the right, you've got assembly, still pretty cryptic, right? And on the left is the same exact logic, but written in C++. Look how much cleaner and shorter that is. You can actually read it and understand what it's trying to do. This jump in readability and productivity is what lit the fuse for the entire software explosion we've seen over the last half-century. All right, so the 3GLs were all about making the process of writing instructions easier. But the 4th generation, it introduced a completely different way of thinking. It was a massive paradigm shift. The goal was no longer to describe how to do something, but to simply state what you wanted the result to be.
This quote just nails it. It's the perfect way to understand the difference. With a 3GL, you're a chef writing out a detailed step-by-step recipe. With a 4GL, you're just telling the waiter what dish you want, and the kitchen figures out how to make it for you.
And the most famous, most perfect example of a 4GL is SQL, the language we use to talk to databases. Look at this command. You are not telling the computer to go find a file, open it up, loop through all the lines, check for a match. No. You are simply declaring your goal. Give me everything from the customer's table. All the hard work, the how, is handled for you behind the scenes.
Now, because of this what, not how approach, 4GLs tend to be specialists. You wouldn't use one to build a whole operating system. But for their specific job, their domain, whether that's wrangling databases, creating business reports, or doing heavy-duty statistical work, they are unbelievably powerful and efficient.
And that brings us to the very top of our ladder, the highest, most abstract level yet. We're now heading to the 5th generation. This is where we go beyond even just declaring a result, and we enter the realm of artificial intelligence, logic, and true problem solving.
Okay, so try to wrap your head around this. A 5th-generation language, or 5GL, is designed so the computer can solve a problem on its own. The programmer doesn't give it a step-by-step algorithm. Instead, you just give it a set of facts, rules, and constraints about the problem, and the system itself uses logic to figure out a solution. It's like being a detective who gives the computer all the clues and asks it to solve the case.
The classic example here is a language called Prolog, which was huge in early AI research. Now, the original dream of 5GLs totally replacing everything else, well, it didn't quite pan out. But the core idea? It is back in a huge way. The AI coding assistants we see today, like GitHub Copilot, are basically the modern version of that 5GL promise. You describe what you want in plain English, and the AI generates the code for you.
So let's just quickly recap our climb up the ladder. We started at the bottom with 1GL, just raw binary. 2GL gave us a hand with assembly mnemonics. 3GL was the revolution of high-level languages like Python. 4GL flipped the script with the what, not how idea in tools like SQL. And finally, 5GL is pushing us into the future with logic, constraints, and AI-powered tools. What a journey.
You know, this whole evolution, this entire climb up the ladder, has been about one thing: making computer languages more like human languages. And that leaves us with a pretty mind-bending final thought. As these AI assistants get scarily good at turning our everyday English into working code, are we actually watching the next generation be born right now? A generation where the programming language is just our own. Something to think about.